Hello there and welcome to A2 Maths. We're on June 2018, paper 1. Here we're looking at question 6, so we can answer a question on lines and circles. The circle C has centre A with coordinates 7, 5. Let's add that on. 7, 5. If it were me on an exam, I'd draw out a nice big diagram with all the appropriate information on it. The line L has equation 2x plus 1, so that's a 1 coordinate there, gradient of 2. And it's a tangent to C at point P, as shown in figure 3. Show that the equation of the line PA, so that's the line from P to A, is 2y plus x equals 17. Well, I know from a circle theorem rule that a tangent must meet a radius at a right angle. So I know that the gradient of AP is going to be perpendicular to the gradient of the line L, so therefore the gradient is going to be minus a half. I also need to know what coordinate is going to intersect P or A at, and I know the coordinate for A is 7, 5, so I'm going to now use that. So set up a y equals mx plus c, that's the equation of a straight line from P to A. And now I can plug in some values. I can plug in the value x equals 7 when y equals 5, and I know the gradient is going to be minus a half. So let's plug them in. 5 equals minus a half times by 7, and then it's going to be plus c, so this is going to be 5 equals minus 7 over 2 plus c. 10 can be represented as 10 over 2, and then we can add the 7 over 2 onto the other side. So that gives us the c value as 17 over 2. So therefore we can say that y is equal to minus 1/2 x plus 17 over 2. Let's now rearrange this to turn it into what we want to turn it into. Let's now double both sides. So we can get 2y equals minus x plus 17, and then we can just add x onto the other side. So we're going to get 2y plus x equals 17. So there we are. That's our answer. Our answer is 2y plus x equals 17. That's the equation of the line from A to P. Okay, let's now move on to part B. Let's write down what we worked out from part A. We worked out that the line from A to P is equal to 2y plus x equals 17. Okay, what we now need to work out in part B is to find the equation of C. Now, what we need for the equation of C is, well, generally circles look like this. It's x minus a squared plus y minus b squared equals r squared, where AB is the centre and r is the radius. Now in the question here, what we have so far is we have the centre. The centre is at the point 7, 5, but we don't have the radius. So we want to work out the distance from A to P. It would be really helpful if we knew what the coordinate P was, because then I can just do P minus A and then just do the magnitude of that. But I don't know the coordinate P yet. So for this question, that's going to be the focus of what I need to work out. I need to work out the coordinate P. Now to work out the coordinate P, I'm going to use two lines. I'm going to use the line 2y plus x equals 17, the one I've just worked out, and the equation of line L. Line L has equation y equals 2x plus 1. And I'm going to use simultaneous equations to work out what x and y are to give me the coordinate P, and then I can work out the distance from A to P, that's the radius, and then I can just substitute it into my equation for a circle. So let's get started then. I'm going to take equation 2 and substitute it into equation 1. So I'm going to have 2 lots of 2x plus 1 plus x equals 17. Expand the brackets, 4x plus 2 plus x equals 17. Group together and take away the 2 onto the other side. So I then get x equals 3. So then the y coordinate using equation number 2 is going to be 2 times 3 is 6 plus 1, that's 7. So I now know that coordinate P is the coordinate 3, 7. So now what I can do, the next stage of my problem is to work out the distance from A to P. How do I get from A to P? Well, that's going to be by the vector 7 to 3 I need to go up to the left by 4, and from 5 to 7 I need to go up by 2. So therefore the distance from A to P is just going to be the square root of -4 squared plus 2 squared, and that's going to give me 16 plus 4, that's 20, so that's going to give me 2 root 5, or in other words, the square root of 20. Okay, great. Now that I know the radius and I know the centre of the circle, my answer, the equation for the circle C, is going to be x minus 7 squared. That's using the coordinates of the centre of the circle. Y plus y minus 5 squared equals, and then it's r squared on the end of the equation of a circle formula, so it's going to be equals 20 as the final answer here. Great, so there we are, that's the equation for C. The line with equation 2x plus k, where k is not equal to 1, is also a tangent to C. Find the value of the constant k. Now, the line 2x plus 1 is this thing here. 2x plus 1 is this line up here. Now what I'm looking for is the equation of this line here that is parallel to this original line L. It's got the same gradient too, but it's got a different k value. The k value will be the y-axis intercept down here. So it's probably going to be a negative value. So what do I already know? I know that the line from A to P is 2y plus x equals 17. And I know that the equation of the circle C is x minus 7 squared plus y minus 5 squared will equal 20. Okay, so how am I now going to move forward with this question? Well, what would be really helpful to know is this coordinate here. That's coordinate P, so I'll call this one coordinate Q. What I've got here is I've got the equation of the line AP, that's 2y plus x equals 17, and then this is y equals 2x plus k. We're not too sure what this k value is, we need to work that out. And what I also know is that how to get from P to A, well, I needed to go 4 right and down by 2 to get from P to A, so that's probably going to be the same vector to get from A to Q. It's to the right by 4 and down by 2. So if I'm at the coordinate 7, 5, and I need to add on the vector of 4 minus 2, then coordinate Q is going to be at the coordinate 11, 3. So I've now got the coordinate of 11, 3, and I can now work out what the k value is going to be. I've got y equals 2x plus k, and I now know that when x equals 11, y is equal to 3. That's the coordinate I've just worked out. This coordinate here is 11, 3. So now I've just got y equals 2x plus k and a coordinate, so I can plug the x value in and the y value in to work out what k is. So I get 3 equals 2 times 11 plus k. That's 3 equals 22 plus k. Take away the 22 from both sides to get minus 19 equals k. So there we are. We've found the value for the constant k. The answer is minus 19. So there we are, that's the answer to question 6, 10 marks for that question there. There were multiple different ways you could have done this part C. You could have worked out that the equation of the circle and the line will make a quadratic eventually if you use them as simultaneous equations, and b squared minus 4ac will equal 0. It's going to take a little bit longer though. It'd be far quicker just to spot that you're going by the vector 4 minus 2, 4 minus 2, to get this coordinate 11, 3. So there we are, that's 10 marks for question 6. Let's now move on to question 7.